Hello everybody! In this video I want to show you the new version 2.0 of the Cinema 4D plugin CX 3D.webdesigner. The name of version 1 was CX HTML5 CSS3 exporter, but that was leading to some misunderstandings what the plugin actually does. So it is not a converter for 3D objects or scenes, but it is a designer tool for creating 3D animated web contents, or better say contents to be displayed in a web browser. That could be web pages, but can also be interactive presentations running on a local machine in full screen mode. In the background you see some examples. An interactive presentation of a kind of folding flyer, a 3D image gallery where the user can navigate through 3D space by clicking on media elements, the C4D project is very simple. Only the camera is animated, focusing each image plane. And here a color configurator running on a touch screen. This is a combination of rendered images, in this case the car, and HTML elements transformed live in 3D space. The selection rings for choosing the colors. The debug window of the browser shows the source code. Here you see the div elements defining the selector rings. But you don't have to care about the HTML stuff if you don't want to. Now let's start creating a simple scene showing the basics of this plugin. You find CX in the plugins menu. The plugin works like an object generator, meaning you make all the required settings here in the attribute manager, and all child objects will be exported to a web project. Since we are dealing with web stuff, we are limited to those objects that can be displayed by a standard browser. Basically, these are just rectangles. Text boxes, images, videos, graphics. These all are just rectangles. The only supported real 3D objects are cubes and cylinders, because they can be composed by rectangles. Okay, so let's start with a simple plane and put it in here. As you can see, the orientation is automatically set to the z-axis. This has to be done because the XY plane is the standard 2D plane. Starting with a simple color material, make it blue. Okay, now a bit of content. Contents are in principle defined by spline objects. Text certainly by a text spline. Hello world. Choosing a font, for example Arial, a bit smaller and centered. Text is only be displayed if it is lying in an extruder object. That's also true for the exported web project. Another material for the text. Moving a bit upwards and a bit away from the plane. Here we add now an image. Images are also defined by a spline. In this case, a rectangle spline. A bit smaller. Again, we need an extruder. Putting in the spline and move it in front of the plane. Now let's create a texture material. Corresponding to our text, a world map. I want to use the transparency of the map, so I copy the image to the alpha channel. And assign it to the object. Don't know at the moment why it is clipped here. So let's try a flat projection. And fit it to the object. Okay, this is how it looks like when rendered. Now let's see what the browser shows. First, some words to the export settings. You have the choice between different types of transformations. 2D and 3D in translation, rotation or matrix notation. The matrix notation is a bit more compact, but not well human readable. The default setting is a good choice, especially if you want to edit HTML code. The time range can be switched between the project and the preview range. The auto start option does what the name implies. The animation will start when the browser has loaded the data. The automatic ID option I switch off, because I want the names of my objects to be written into the HTML code. Otherwise, the exporter creates serially numbered IDs. But you have to care about unique names, so let me just rename our objects. Okay. Content objects always have to be placed inside of a node object. Remember, content is defined by splines. Planes, cubes, cylinders, etc. and of course null objects are node objects. Only node objects can be animated. Back to the export settings. Here we have the stage parameters. The size can be copied from the render settings, the stage of the display area, and can optionally be centered in the browser window. The clipping option cuts all objects to that area. The output is written into a template file. CX comes with 2 different template files, but you are free to create your own ones. You just have to include certain placeholders for the output data. The appendix in the manual describes the details. Now we have to choose a file name for the output file. I take the chance to save the cinema project too. Some further options here. The so-called browser prefixes are used to increase compatibility. You can set prefixes for transformations and graphic features. New features that are not yet standard are often supported by the browser if they are marked with a prefix. Nowadays, all current browsers support 3D transformations, so you don't have to check this option. But for certain graphic features like gradients or alpha mask images, it is recommended to enable the prefixes. So I click on Export to get the Hello World HTML file that can be opened by the browser. How you can see, it looks almost like the rendering. Before animating the object, I want to add a gradient for the background. Choose a background object. Create a material. And select a gradient shader. Assign to the background object and put this in the CX object so that it can be found when exporting the project. Now let's make some animations. I want the object to come into view from right while rotating to the front in 2 seconds. So this stage should be the final one. Make a keyframe. And make the initial state. Positioning right outside the stage and turn, say, 90 degrees and record the state. So I get this simple intro animation. Let's view it in the browser. Export, refresh, and nothing. Okay, CX1 just exported the keyframe animations. Since version 2 now supports styles and transitions, I'll come to that issue in a few moments, we have to tell the exporter what we actually want. For this purpose, there is a new tag to be found in the tags menu. In this action tag, I have to enable keyframe animation explicitly. Otherwise, the object states at the timeline positions are exported as style classes. More on this in a few moments. The keyframe animation can be activated for single objects and entire groups. In latter case, you have to enable include child objects. So once again exporting and checking the browser. Okay. We can set a small delay in order to give the browser some time to load the media. At the moment the output is limited to the stage area. If I switch off clipping, the entire browser window is used for the display. With the disadvantage that the object is also visible when it is outside of the stage. So I'll add a fade in. Therefore we use a display tag. I set the visibility of the final state to 100% and record. And at time 0 to 0% in record. Exporting and checking the browser. Now it is faded in together with the moving. Before we come to interactivity, Let me add another keyframe. Maybe we can let the object disappear. Again turning, maybe backwards. And moving into the background. And fade it out by simply copying the first key. Let's see. Okay. Should look the same in the browser. Fine. Now we come to interactivity. The basic difference is that these keys are not exported as a linear animation, but define different object states that can be recalled at any time. In this example, we have the initial state, the mid state, and the end state. I could add any number of keys to define further states. It's a good idea to use timeline markers so we can use names for our styles instead of working with frame numbers. Here we have the end state, and that's the mid state, or say normal, and the start. Okay, so we no longer want a linear animation for our plane, but call the different states by mouse clicks. Therefore, I first remove the action tag of the master object. Next, we need another object the user can click on. I make it a bit smaller. And move it to the foreground. Again, we need a material. Maybe a red cube. By the way, I show you another display option. Again, by using a display tag. We can use one of the line shading modes to get borders around the surfaces. The border color is taken from the object color defined in the basic settings of the object. Okay, so let's see how it looks so far. Here is the red cube with white borders. The Hello World plane won't appear because, as you remember, I removed the action tag. Now we want to call an object state defined by keyframes when clicking on the cube. So I attach an action tag to the cube and add an event. By default, a click event is selected. There are different events to choose from. Mouse events, touch events, if you want to explicitly support touchscreens, and certain events that occur with animations and transitions. You can add further event types in the events list of the JavaScript panel of the CX object. You can add any event that is supported by the browser. In the action menu we find the names of our timeline markers that we can choose as the action. So I select normal because I want the plane to appear when I click on the cube. So the plane has to be assigned as target. If I would not assign a target, all objects that have keys at that time position would be involved. Again exporting and refreshing the browser. At the first look no difference, but now I get the pointer mouse and can click on the cube. And voila, the plane appears. Now let's add another action to make the plane disappear. I assign an action tag to the plane. Add a click event and choose the end state as action. Exporting the plane appears. It's now clickable too and disappears when clicking. Styles and keyframe animations can be set for each object individually. For example, the cube could rotate in a permanent loop. So let's record a simple rotation. 90 degrees at frame 90. Since a cube looks the same from all sides, this is enough for a complete rotation. The cube has already an action tag, so I just have to enable the keyframe animation. In this case, cycle. Individual sequences has to be enabled because I want the animation to loop between frames 0 and 90, not over the time range of the project. Let's check the animation here. Okay. Again exporting and refreshing the browser. The cube turns, but not continuously because the key interpolation is still set to spline. To make a uniform rotation, I have to set the interpolation to linear. Okay, now the cube rotates as it should and is certainly still interactive. Thank you for watching this video.